So we have here a difficulty 3 level problem on the CLT. Recall that there are 5 quantitative reasoning difficulty levels. So this is right around the middle of the section. You might come across a question like this. A student is studying scalene triangles and comes up with the following conjecture. Scalene triangles are never also right triangles. Which of the following is a counterexample that disproves the above statement? I like this question because of how it ties together math and logic. Notice the formal logic aspects of this question. So we need to cover some vocabulary first, and then we'll talk about the formal logic. First off, we have the word conjecture, not completely necessary to answer the question, but the kind of thing that it's helpful to know that that's sort of an educated guess that a student might be making. Now then we have the all-important word scalene. A scalene triangle is going to mean no equal sides. We have isosceles, 2 equal sides, equilateral, 3 equal sides. Scalene triangles have no equal sides. So this student is suggesting that if a triangle is scalene, that is, that it has no sides that are congruent to each other, it can never also be a right triangle. Now let's think about the formal logic aspects of this, the kind of if-then nature of what's going on. If we want to find a counterexample, we have to be careful how we do that. Let's say, for example, that I made the statements, all cats have fur. All cats have fur. Now let's say you wanted to disprove that statement. One thing that you couldn't do is to say, now wait a minute, I have before me a lizard and it doesn't have fur. So what you just said is false. You can't begin a counterexample by denying the premise or the sufficient condition of what's being said. We're not going to start out by saying something is not a cat. That's not going to help us find a counterexample. Instead, what we need to do is bring before ourselves a cat in our minds, right? Or maybe in reality, and say, once we've established that we have a cat in front of us, it is part of the genus Felis or whatever, feline, right? It is a cat. Does it have fur? Are there any exceptions? Well, there are, surprisingly, perhaps, Sphinx cats that don't have any fur. So we actually can make a counterexample to the statement, all cats have fur, but only if we accept first that we have a cat. Now think about the implications of that. We have to begin with a scalene triangle if we're going to find a counterexample. If we don't do that, it's like bringing up the lizard in my example. So if you look at the choices here, a couple of them fail that test. They don't begin with a scalene triangle. Choice A is an isosceles triangle. Choice D is an equilateral triangle. Only B and C even begin with scalene triangles. Now we want to find a counterexample, which means we need to negate the statement that in this case is universally negative. Scalene triangles are never also right triangles. Negating a never makes it positive sometimes, or can we find one example where a scalene triangle is a right triangle? That's our task as we look at the remaining choices. Notice, by the way, how I'm focusing on important words. You might write down scalene on your scratch paper, and considering the choices early in my thought process. That's the beauty of multiple choice. We're left with B and C, and we want to find a right triangle. You may recall that if we want to do that, we can use the Pythagorean theorem. A squared plus B squared equals C squared. We need, for our right answer to resolve or to be a solution to the Pythagorean theorem. Now, you might also, though, notice a shortcut. If you've been well taught in geometry, you may recall there's something called Pythagorean triples. I won't even try to spell the word Pythagorean there. Let's just abbreviate it. Pythagorean triples are whole number sets that are solutions to the Pythagorean theorem. One example would be 5, 12, 13, because 5 squared plus 12 squared equals 13 squared. But the most famous example is right here, because 3 squared, that is 9, plus 4 squared, that is 16, equals 5 squared, that is 25. So we know that answer B is our answer because it is a scalene triangle that is nevertheless a right triangle. So it serves as a counterexample. If you try C to confirm and plug it into a squared plus b squared equals c squared, you will find that 4 squared plus 5 squared does not equal 6 squared. So we'll fully confirm there. And we have an approach to counterexample questions that takes into account the vocabulary, like scalene, the formal logic of what we're trying to do and what we're not trying to do, and the underlying geometry of this question.